Hello dear learners, welcome to our new video of advanced mathematics. In this video we will discuss the some properties of common divisions. There are some properties which we are going to prove one by one. So let's start our video class. This is the theorem number 3 of your textbook. It is that for the integers a, b and c are integers, we have to prove that a divides 0. This is division sign. It is read as a divides 0. 1 divides a divides a. In such a way, these things are read. So, first one, we have to prove there are three things. First of all, we have to prove that a divides 0. And secondly, we have to prove that 1 divides a. And then we have to prove that a divides a. So let's start it. So we know that for any integers, suppose 3 is an integer, no? So we can write 3 into 0 is equal to 0, yes or not? So if we consider a is any integer, it is given in the theorem that a, b, c are integers. Since a is integers, we can write for any integer a not equal to 0. A is an integer which is not equal to 0. We can write a into 0. This is a into 0, or you can give cross sign here, is equal to 0, yes or not? From this line we can conclude that suppose 6 is an integer and 2 is another integer. If we divide 6 by 2, then it divides 3 times, so 2 3s are 6. So 6 can be written as 2 into 3, no? That means if we divide any number by any integer by some integer, then we get a third integer. Suppose here 6 is an integer and 2 is some another integer. If we divide 6 by 2, then we get some integers such that their multiplication give the main integer. That means 2 into 3 can be written as 6. That means 2 divide 6 or 3 divide what? 6. Here see, from this line we can conclude that by definition of from the definition of division, we can write from definition of division see, a into 0 is equal to 0. That means a is integer, 0 is an integer, so a into something is equal to 0. Suppose 2 into 3 is equal to 6. It means that 2 divides 6. So a into 0 is equal to 0. That means a divides 0. Yes or not? 2 into 3 is equal to 6. From this line we can say that 3 divides 6. Because if we divide 6 by 2, then we get 3. So in this case, the same case arises here. A into 0 is equal to 0. That means a divides 0. And how many times a divides 0? 0 times, no? So from definition of division we can write a divides 0, no? The first one is proved. For second one we can write again. It is first written for any integer a is not equal to 0. We can write a into 0 is equal to 0. Again a into 1 is equal to what? A, or a is equal to 1 into a. If we write this line in this way, suppose these things in this side, so or from this line we can go to see a into 1 is equal to a. From this line what can you conclude? S, like 2 into 3 is equal to 6. 2 divide what? 6, or 3 divide 6. Now we have written a into 1 is equal to a into 1 into anything is equal to that thing. So a into 1 is equal to a. From here we can write it either a divides a or 1 divides a, yes or not. Therefore what can we write? 1 divides a. 1 divides a. So if 1 divides a, then in this, for this case, if we say 2 divides 6, it is also correct. 3 divides 6, it is also correct. So for this thing, a divides a is also correct. 1 divides a is also correct. That means 1 divides a is correct and a divides a. For the same reason we can write this, no? So first one is proved. So we will proceed to the next one. So next property of division is that a divides 1 if and only if a is equal to plus minus 1. This is 1. That means a will divide 1, no? When a will divide 1, suppose these things, a will divide 1. When a will divide 1, if we put the value of a either 1 by 1 or 1 by minus 1, because 1 divides 1 one time, minus 1 divides 1 minus 1 times. Other than these two values of a, it is not true, because if we put a is equal to 2, then it will not completely divide 1, but 1 is completely dividing 1 and minus 1 also completely dividing 1. So we have to prove that a will divide 1 if and only if a is equal to plus minus 1. That means a can take the values 1 or plus 1, minus 1, plus 1 or minus 1. So let's start it. First of all, we will let that a divide 1, then we will prove that a is equal to plus minus 1. So either you can take a is equal to plus minus 1, then you can prove this one, or you can take first of all you can assume it, then you have to prove this one. So first of all, we have considered that a is dividing 1, that means a divides a, it is assumed. Now we will prove that the value of a is plus minus 1. See, when a divides 1, then we get, suppose when 2 divides 6, when 2 divides 6, we get 3, some integer. That means 6 can be written as 2 into 3. So in the same way, when a divides 1, that means a is divisor and 1 is dividend. So we can write, from this line we can write, implies 1 is equal to a into some integer. Suppose here 2 divides 6, 2 divides 6 implies that 6 is equal to 2 into something, that something is 3, and in this case a is dividing a, 1, so 1 is dividend. 1 can be written as like this way, 1 can be written as 1 is equal to a into something, and that something is taken as, suppose c. You have to write where c is some integer, Why you can write? From the law definition of division. If a divides something, that means if a integer divides another integer, then we get some result, no? When 2 divides 6, we get result 3. So when a divides 1, then we get some result c. That means a into c is equal to 1, no? Now see, a into c is equal to 1. This is possible. A into c is 1 when this is possible. When it is possible, it is possible only when a is equal to 1 or c is equal to 1 and a is equal to minus 1 or c is equal to minus 1. That means if we put a 1 and c 1, then 1 into 1 1, and if we put a value of a is minus 1 and c into minus 1, minus 1 into minus 1 is also 1, 1 into 1 is also 1. So in the two case, this equation is possible. Now see, you can question me that, sir, this one is also possible, that 2 divide 1 by 2 is also 1. Yes or no? Yes, it is correct. 2 into, if we take value of a is 2 and value of c is 1 by 2, then it is also correct. But the twist is that as we know a and c are integers, so we cannot take the value c as half, because half is not an integer, and here it should be an integer. So this equation is possible only for the values of a and c, these values, for a is equal to 1 or c is equal to 1, or a is equal to 1 or c is equal to minus 1, a is equal to minus 1. That means what we are getting, that means from if a divides 1, we are getting a can take only two values, either 1 or minus 1. So we can write from these things, we can write a is equal to plus minus 1. Therefore we can write a is equal to what value I can take, either 1 or minus 1, that means plus minus 1. That's it. Very easy. Just you have to see it concentratedly. Now see 3 number property. 3 number property is that a divides b and c divides d, then ac divides bd. That means when a divides b and c divides d, then ac divides bd. No, these things we need to prove. Now see, let a divides b and c divides d. These two things are assumed and we will prove this one. Now see, from this line a divides b, a is dividing b as like previous one. 2 is dividing 6. 2 divides 6 can be written as 6 is equal to 2 into 3. That means 2 into some integer. That integer is 3. It is known for us, but since the value of b is not known for us, so we will get, when b will be divided by a, we will get some result or some quotient. So from this line we can write b is equal to a into something. That a into something taken as, suppose a into r, where r is some integer. You have to write r is some integer. From this line again c divides d. So from this one also c is dividing d, so we will get some result. So d is dividend, d is equal to c into something. Suppose c is equal to c into s, where s is some integer. No? Now see, we need to prove that AC divides BD. So we have to prove that AC divides BD. So first of all find the value of BD, then we will see whether AC is dividing BD or not. Or you can write directly. Now we have to prove that AC divides BD. No? AC divide BD. AC divide BD. This is nothing but this can be written as what? AC by BD. No? AC by BD. Since this is division sign, so we can write in this way also. Now see, value of AC. Sorry, this can be written as BD by AC, since AC is dividing. BD by AC. Now see, put the way we have to prove whether AC is dividing BD or not. Now see, put the value of B. What is B? B is A into R. A into R, and D remains same. And here what? AC. No, we have the value of D, so put the value of D. D means CS. C into S. No? C into S. C into S divided by AC. Now see, here A and C can be written together. AC into R and S can be written together. no? And in the denominator we have AC. So this AC and AC get cancelled, that means AC is dividing BD. So here this thing is nothing but the value of BD means these things, and AC. So AC is dividing this thing means what? AC is dividing B, RS. Therefore we can write AC divide BD. So this thing you can prove in another way. I am doing that one also. So from here AC divides BD, we need to prove. So find the value of BD. Here BD is equal to what? B means A into R and D means C into S. So here you can write A into C equal to R into S. Now from this line, see, A is multiplying her. So if we take A this side, it will divide BD. That means we can write AC divide BD. So in this way you can solve this part also. Next properties is that if A divide B and B divide C, then we have to prove that A divides C. If A divide B, B divides C. Suppose if it is like that, if 2 divides 6 and 6 divide 12, then 2 also divide 12. These things. If 2 divides 6 and 6 divides another integer 12, then the first integer is also divides last integer. So A divides B and this B divides something C, then we have to prove that A divides this C. No? Because why? Because A is already in B and B divides something means what? A is also dividing C. So now we will prove it. Let A divide B and B divide C. We will prove that A divides C. For A divide B, we can write B is equal to A into something, suppose A into R, and here we can write from this line B into divide C means what? C is equal to B into something, suppose S. No? Now see, we need to prove that A divide C also. Now see here. So see, what is the value of B? B means what? A into R. A into R and S remains same. So C is here. And here we can write A into RS. No? Now see, A is multiplying here. So if we, that means C is equal to A into some integer. RS is product of two integer is an integer. So RS is an integer here and A. That means C is written as A into some integer. No? So we can write, or if we take the A this side, here it is multiplication. So if we take this side, it will divide C. No? So we can write therefore A divides C. A is dividing C. If we take A this side, we will get RS some integer value. So A divides C. Next one, see. 5 number is that if A divides B, if A divides B and B divides A, then A is equal to plus minus B. That means A is dividing B and B is dividing A. Suppose like in this way, A is dividing B and B also divides A. A divides B and B also divides A. Then A and B should be equal in this way. A means if we take A 2, divide 2 and 2 also, this should also divide 2. So in this way we can write this is also possible, and minus 2 divides minus 2, this is also possible. That means the value of A will be equal and in plus minus, or you can write 2 divides 2 and 2 divides minus 2 and minus 2 also divides 2. So this case, that means when A will divide B and B will divide reversely A, then A and B are equal and they have opposite signs. So let's take, let A divides B and B divides A. B divides A. So from this line we can write A divides B means what? B is equal to A into something, A into R. From this line we can write A is equal to B into something, suppose S, where R and S belongs to Z. That means some integer. R and S are some integers. Now see, in this case B is equal to AR. What is the value of A? BS. So in place of A we can put BS. So BS into R. No? Now see, from both sides B and B get cancelled. That means 1 is equal to S into R. So again the same case arises as the number 2. So 1 is equal to SR. When it is possible? When it is possible, when it is possible, either S should be equal to 1 and R should be equal to 1. That is 1 into 1 is equal to 1, or minus 1 into minus 1 is equal to 1. So to get 1 by product of some integers, we have to consider only possible for this integer, 1 into 1 or minus 1 into minus 1. Then we will get 1. Suppose 3 into minus 1 by 3 is also correct, but 1 by 3 is not integer, so we cannot consider, because S and R both are integers here. So it is possible only when S is equal to 1 or R is equal to 1 and S is equal to minus 1 and R is equal to minus 1. For these two values, this thing is possible. So the value of S is, therefore S is plus minus 1 and R is also plus minus 1. No? That is, when if we put in this equation, suppose this is equation number 1. So 1 implies in equation 1, if we put the value of S, that is A is equal to B into S. S means what? Plus minus 1. So this can be written as plus minus 1 into 1 into B means 1 and plus minus B. So A is equal to plus minus B by putting the value of S in equation 1. Equation 1 is A is equal to B into S. So value of S is put here. A is equal to B into S. S means plus minus 1. So 1 into B is B and plus minus 1 remains same. These things. See 6 number property. If A divides B and B is not equal to 0, then modulus of A is less than or equal to modulus of B. That means if A divides B and B is not equal to 0, means if 3 divides, suppose 12 and 12 is not 0, in this case modulus of 3 is either less, modulus of 3 means positive value of this, positive value of 3 is 3, is either less or maybe equal, because 12 divided 12 is also true. No? So this value, this A either less than B or equal to B, and the values should be positive. That is modulus of A. That means positive value of A either less than positive value of B or equal to positive value of B. We have to prove this one. Now see, let A divides B. So from this line, what can we write? B is equal to A into some integer, suppose R, where R belongs to Z. R belongs to Z. So since B is not equal to 0, B is not equal to 0, we have considered, since B is not equal to 0, then this R will also be not equal to 0, because B is not equal to 0 means what? B has some positive values. No? Suppose 12 and here 3. So if 3 divides 12, then we get 4, which is also not 0. It may be, and 12 divided 12, it is also correct, which is also not 0. That means if b is not equal to 0, then r a into, if b becomes 0, then a into 0 will be 0. In that case r will be 0, but here b is not 0, so a into something, that something should not be, must not be 0. No, if we consider 0, then a into 0 will be 0, then the value of b will also be 0. Since b is not equal to 0, therefore we can write r is also not equal to 0. R is also not equal to 0. Therefore we can write, that means the value of r either greater than 0, either the value of r, either it will be 1 or greater than 1. Since r is not equal to 0, that means r may take the value 1 or greater than 1. That means if we consider the positive value only, that means therefore what can we write? Modulus of r either 1 or greater than 1. 1 or greater than 1. Why modulus of r is greater than 1? Because since r is not taking 0, that means r will be greater than 1 or maybe 1, and since we are considering only positive values here, so modulus of r will be greater than 1 or equal to 1. No, now see, now we have b is equal to a into r. So if we take modulus both sides, if we take modulus of b, then we have to take modulus of a r, and this thing can be written as modulus of a into modulus of r. Modulus of r. Now see, this thing, modulus of a and modulus of b, they are multiplying each other. This thing is what? Modulus of a is some value, modulus of r is some value. It may be 1 or greater than 1. So this thing is greater than or equal to, this whole thing is greater than modulus of a, yes or not? This whole thing is greater than modulus of a or equal to modulus of a, because when r will be 1, then modulus of a will be equal to modulus of a. Since r is taking either 1 or greater than 1, when r will be greater than 1, then modulus of a into some value is greater than only modulus of a. It is only modulus of a. No, so modulus of, if we write modulus of a into 2, it is greater than modulus of a or not? Yes, because here 2 modulus a is there, and here only modulus of a is there. That means it can be, it is greater. No, when r will take the value 1, then in that case it will be equal. So since this thing is nothing but b, so we can write, therefore this thing is what? This thing is b, modulus of b. So therefore we can write modulus of b is greater than or equal to